this module, we'll look at Python fundamentals. We'll begin from scratch and learn what Python is and what are the kind of things that you need to use. If you've never worked with any programming language, if this is your first programming language introduction, then don't worry, we'll begin everything from scratch and we'll understand how to get started with Python and how to learn the basics fundamentals of Python. So let's take a look at the agenda. We'll begin by getting an introduction to Python. We'll understand what is Python. Then we'll take a look at Python variables. We'll understand what variables are and how to use them. Then we'll understand tokens. Tokens are the fundamental building blocks of any programming language, and we'll take a look at what tokens are in context of Python as a programming language. Then we'll take a look at data types in Python. Then we'll take a look at conditional statements. How do you make decisions based on a certain condition? Then we'll take a look at looping statements. How do you perform some task multiple times? Then we'll take a look at Python functions, which are basically a way for us to abstract some of our code away, and we'll take a look at how to do that. Then we'll take a look at arrays, which allows us to store multiple data elements in one form. And finally, we'll take a look at how to handle file operations using Python. So let's take a look at them. So let's have an introduction to Python. So Python is an object-oriented, interpreted, high-level programming language. It is general purpose and is used to develop GUI and web applications. Now, Python is an object-oriented programming language. Object-oriented basically means it's a way of structuring your application such that real-world concepts could be modeled inside it. I know this sounds a bit vague as of now, but in the next module, we'll cover what object-oriented programming is, so don't worry about that. And then we have to learn about interpreted. So there are two kinds of programming languages, interpreted and compiled. Compiled languages are firstly, you write the source code and you compile it. It's completely converted into machine code, and that machine code is then run. On the other hand, in Python, what happens is you give the interpreter the file that you've written the code in, and what it does is that it takes a look at each line of the code and tries to execute that line instead of reading the file top to bottom and converting it into machine code. Each of those lines is converted to code. So if there is an error in your code at line 6, line 1 to 5 will be executed and their output will be displayed. Line 6 will not be executed or will throw an error while being executed. It's a high-level programming language. That means that there are a lot of things that you wouldn't have to worry about when you're working with Python. Things like memory management, creating pointers, creating memory resources, and then releasing those memory resources once you're done with the process. Now, these are the kind of things that you would have to do in a language that is low level or mid level. A language like C and C++, you might have to do that. But in Python, you don't have to do that. You only need to worry about the code that you're going to write, and Python will take care of memory management, allocating and deallocating memory, and everything like that. Python is used to develop GUI and web applications. It's used to develop a lot of kind of applications. You can build command line applications. You can build a machine learning or data science machine learning model. You can build a simple script. You can write an entire web application, which is you can program a web server, or you can build a GUI desktop application. There's really a lot of things that you can do using Python, which is why it's one of the most popular programming languages out there. So with Python, we can concentrate on the business logic rather than investing a lot of time in common programming tasks. So as I've already discussed, it's a high level language. That means that you don't have to worry about allocating and deallocating memory. You don't have to worry about many other tasks that aren't really related to the application that you're writing, but are just some common programming tasks. These will all be taken care of with Python. So you can mostly take care of writing code that makes your application work, and all the plumbing will be taken care of by Python. So Python was created by Guido van Rossum. The image of the screen is of the person who created it. It's of Guido van Rossum. He was a Google employee, and he released the Python 0.9 version, which was the first published version, in 1991. Then it grew a lot of popularity, and it was released with version 1 in January of 1994. And from there, it's taken on, and it's currently in the version 3.8. It's probably one of the most popular programming languages out there. Certainly the most influential of all the programming languages that we have worked with so far. Certainly one of the most easiest one to take a look at. And it's very easy to use. That's why it's grown in popularity so much. So if you've ever wondered why Python is called Python. I mean, Python, as in the name of the language is Python and not something else. That's mainly because it was named after a BBC show called Monty Python's Flying Circus. So Monty Python was a British comedy group, and they had a TV show which was very popular at the time. It was called Monty Python's Flying Circus. So that is why and I think Guido von Rossum was quite invested in that program. So that's why it was called Python. The language was called Python. Many languages have been given the names based on something that was observed by their creators. So there are a lot of languages that you can learn. As you already know, there are many languages that have already come before Python and are still being invented. So why are we going to learn Python? What advantage does Python provide that we should focus on learning Python rather than any other language, say C++, C, Java, or any other language? Well, the major advantage that Python provides is that it's very simple and easy to learn. You can learn Python quite easily. It's probably the easiest language to learn out there. And it has libraries for almost everything. So it doesn't matter what you want to build. If you have any kind of niche problem, there's a good chance that there's a library that has been created by some other developer for you to use. So it doesn't matter what you have to do. If you want to build a web server, you can use Django or Flask. These are two libraries that can be used to do that. Now, let's say that you want to visualize some data, you can use Matplotlib. Let's say that you want to manipulate some data, there's Pandas for it. You have a lot of libraries, so you don't have to code everything from scratch and build code that could parse files and then manipulate it and do it for you. You can easily use someone else's written code because Python is so popular. Many people have written a lot of code, and a lot of the problems that you might face while developing an application might have already been solved if you take a look at the library code. It's reliable, efficient, and time saving. Since Python is easy to learn and it's got a very clear and succinct syntax, you don't have to write a lot of code in order to do something. That way, it saves a lot of development time, it saves a lot of headaches. It's very efficient. Given the fact that you don't have to write a lot of code, there's not a lot of performance deterioration. You can have a really good performance, and given that you're writing the code the correct way, you can have a good performing Python code depending on how you're writing the code. And it's very reliable. Many great applications have been built on it. Many high traffic applications that are being used by many people across the globe are built on Python. The fourth advantage would be that it has a large and active open source community. Since Python is so popular, it's got a large community of developers. So if ever you run into a problem, you could post it on a forum, and other Python developers could help you out in no time. Having a large community is really helpful thing. This also leads to the point that we have a lot of libraries because it's got a large open source community, so people contribute to other people's codes and libraries where they fit. Then it offers career opportunities in various fields. Since Python is so popular, Python is used in almost all the fields where computer programming is used. It's used in NASA. It's used in web applications such as Instagram and all that. It's used in simple scripts that you can write for automating some things that you want to automate. There are multiple things that you can do with Python, and because of which it provides you opportunities in several fields. So where can you use Python? Now that's a really interesting question, mainly because you don't really know where you can use Python. So as I've already told you, Python is by far one of the most popular programming languages out there. And it's so popular that it has been used to build a lot of different kinds of things. You can build a web application using a library such as Django or Flask or Tornado, and there are many others as well. You can use it to build desktop applications using PyGTK, or Coco. These are libraries that help you do that. You can also build machine learning, data science, or deep learning models using sklearn, TensorFlow, Theano, Spark, Keras, and so on. And you could use it to build cloud applications that can work well with the cloud infrastructure. So things like OpenStack API and Cloud Fabric, these are kinds of things that allow you to do it. Cloud and DevOps is something that you could very well integrate with your Python applications. And then there's hardware programming. So it's true that you can write hardware programming using C, but Raspberry Pi, which is a really small integrated circuit that allows you to program a computer yourself, it allows you to use Python to program it and write code on it. So it's very useful. So let's take a look at some of the companies that use Python. So Google uses Python, Netflix uses Python, NASA uses Python, Raspberry Pi uses Python, YouTube uses Python, Facebook uses Python, National Security Agency of USA or NSA uses Python, and Trivago, BitTorrent, Dropbox. These are just a small subset, but as you can see, there are many giant tech firms that use Python, as well as many different fields like the scientific computing field in NASA, the hardware programming field in Raspberry Pi, or some national security agencies. They use it as well. So you can see that Python works on a lot of scales. It can work for smaller applications and it can work for really gigantic applications as well. So how do you get started with Python? Well, the first thing you have to do is you have to install Python. Now to install Python, you depending on the operating system that you have, you will have several ways of doing it. First thing, if you are using one of the mentioned Linux distributions, so things like Ubuntu, Fedora, or CentOS, we have provided you with the commands that you can run. So you can run sudo apt get install Python 3.8. This will help you install Python 3.8 on your system. If you're using Fedora, you can use sudo dnf install Python 3. The reason why the commands are different is because these Linux distributions use different package managers. The package managers are used to install different applications on your system. So type these commands in your terminal or command prompt, and if you're on Linux or one of these distributions of Linux, then you can do that. If you're in Windows like I am, you can go to python.org/downloads and download the version of Python that you want. There are two versions. Let me just show you. If I go to python.org, and when I go to python.org, I go to downloads and I can download Python 3.8.2. I want to download it for Windows. If you are on Mac, you can do it here, and if you want to do it for other platforms, you can click here. Since I'm on Windows, I'll click here. As you can see, we have Python 3.7.7. The latest version is Python 3.8, but you could also download a previous version, and that's Python 2.7.17. Now, the reason why we have two versions of Python, Python 2.7 and 3.8, is mainly because Python 3 is backwards incompatible. So there are many things in Python 3 that were changed from Python 2. So if you're using Python 2, if you have an application that has already built in Python 2, then moving it to Python 3 is going to be a really difficult task. This is why Python 2.7 is always, Python 2.7 is not something that is encouraged to be learned by new developers. So if you're just starting with Python, use Python 3.8. But if you know that you're going to be working with an older system of Python, then maybe you can use Python through 2.7 as well. But as of now, we'll use Python 3.8. So I click on this, and this tells me a lot of information about it. I can take a look at it. I can take a look at Windows binaries. For Mac users, you can do it this way. And these are the files that are there. Now I am using Windows, right? So I can choose Windows, and I am using 64-bit and executable installer. So I click on this and it'll download it for me. Let me just show you. So it's downloading. I think I clicked on the wrong file, but you could click here and it's downloading for me. So it's 26.3 megabytes, so it's not that big when you think of it. And you can run it and install it. It's as simple installing as clicking the next button and clicking on the finish icon. I already have it installed, so I'm not going to do it again. So once you do that, then you can follow along with the session as well. So let's get back to where we were. Now that you know how to download Python and install it, let's move ahead. Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly, and click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me. And once you're done with this, press enter. And as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the curly, the parentheses there? We'll discuss all of that in a future video. But note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code, and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console. But here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter. And if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that, okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now, the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it b plus c. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took b and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSDA and CSS. And as you can see that it added it to the it added those two strings together. Now, if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number. Let's say that you were giving an exam and they say add a plus 15. That would make no sense. And the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called A, B, C, D, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age, n equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now, if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there. So you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start it with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B, and C to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15, and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B, and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B, and C, if I were to use B, C, and A, then B will be assigned 10, C will be assigned 15, and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. All right, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic. Then there's assignment operator. There's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is we'll take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use and. It will return true if both the statements are true. Similarly, there's an or statement. Or statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter. And it returns false because one of those conditions is false. So that is the problem because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to let's say 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use instead of and I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand. So let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented or any value is represented using binary. So binary is basically just some combination of zeros and one. So when you hear something like integer can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have this will be 0 since all the 4 numbers are 0. Now what we're doing is I want to check if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so that. So 4, 8, 4, 2, 1. So what happens is if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3. This should be 2. Should be 1. This should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1, so we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating this sequence in which we go 2 to the power of 3 is 8 multiplied by 0, plus 2 to the power of 2, which is 4, multiplied by 1 is 1. Then we go 2 to the power of 1, which is 2, multiplied by 0, and we go 2 to the power of 0, which is 1, multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1, and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space. We can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary AND and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be 0. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I've given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the left shift operator does. It takes the binary format and shifts it by 2. Now, on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left there are nothing there, so it's removed, and add two zeros at the begin, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python, and I were to use the ID method, and I were to pass it a number 1. You see this long number. This is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to type, try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752, and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it, and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4, and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, And now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discussed are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory. It has to create something on the call stack. It has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code. And we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others. And these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type ret is equals to 7, this works just fine. But if I were to type return return, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every characters in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v, small a, and small r equals to 7, and if I equals to 8, And if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's, you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, and it's 72. So if I were to print var with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 var equals to 7. We'll get a syntax error. But if I were to do it v1ar, this is just fine. It will work. v1ar, and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, Boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path, press enter, and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now, the way it worked in Java and C and C++ was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that, you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. Just need to understand why there's two quotes and why there's one quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter, it's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type 3 single quotations, press enter. I get back the prompt with 3 arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again uh, starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers, so we can store that in integer as well. Let's say that I want to store -77. I can store it in number, or +77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now, there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number. when the number becomes large. Python will do it for you automatically. It will take a look at the number. It will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type BOL, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that could that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers, and tuples will have some value assigned to them. And then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable, we have lists, dictionaries, sets, and in lists, we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number, and a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this. And if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that, I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now, another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the fifth character, or this the sixth character in this, which is on the fifth index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the fifth character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the last, removing the last one character. If I were to remove the last 2 characters, I can do this. and this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it'll do that here. But let me just show you. Replace f with g. I press enter, it returns another string to me, which is A, B, C, D, E, G, G, H. Now, if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying, give me another string in which you have replaced all the F's with G's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O, or U, and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable. But again, it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me. Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to add something to the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now, this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousand. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the to the person's current salary. Now there are many ways to do it. First way to do it would be uh, salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple, 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple to see if it's a tuple or not. And it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add two curly braces. Inside it, add the key, which would be the person's name, let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter. And now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good. But one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. I press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is, if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. but you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets. Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? Set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in s, and it will show you 2. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do 1 in s as well. If I were to assign a list of 1 comma 2 to it, and then instead of 1 in s I can type 1 in l, and that will return true as well. The difference here is that it takes a look at all the elements 1, 2 and whatever, and finds if something exists in it or not. Whereas in set it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good, but let me just exit out of it. When you want to type in a lot of code and you want to open a code file and execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window, and here type in VS Code, press enter, and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open with this code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py, and right and click on edit. It will open it in Notepad, and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this, and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go on to the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder, so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. So you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to a closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well, so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I printed it's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that we want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num 0, and then I keep going on like print num1, num2, num3, so print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understand what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parenthesis, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter, and pop is also not available. But you can print them, you can loop over them, just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this dictionary, or let's say I'll call it self. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys. These are the values. So Jane earns 15. John earns 20. So we type it. We print in the keys. Now, if you don't want to print the keys, let's say we want to print the values. I do that. Now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now, another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now, if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X. As you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for X in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10 because the end is exclusive. So always remember that. And now if I do L dot append X, and finally we can print X, not XL. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code, because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add X to the list. Now Python is waiting for me to define what X is. So I'll go for X in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier. And this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this, I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and so you will get run into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements one and everything before the else statement gets executed. But if say the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand if the condition is true, then statements one is going to execute, and if condition is false, we'll execute the else statement, which is the statements two. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true, then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Run this again, it's correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else Again, write some code. X is greater than 15, and finally else X is greater than 20. So if I run this, X is less than 10, 20, and X is less than 15, which is true. Now if I were to give it a value something between 15 and 20, X is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We assign a value of 17 to X. We check this condition. We check if X is less than 20. It is less than 20. We go down. We print X is less than 20. We go down. We check X is if it's less than 15. It's also true. So we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type X is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if X is less than 20. Well, X is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read if you can do it like this as well. If X is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on. So don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names Let's say that I have a list of name from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if anything, if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flow chart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does. And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So end space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and a space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping, we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this, done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list and you don't want to print the name of people whose salary is less than, let's say, 40K. So what you can do, if person, let's say that for each x0 index is the x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. But it'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. While, or another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when as you can see, if I can travel back in time, yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1, I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you have working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements. Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform. If that's the case, then you don't return anything, you just omit the return statement completely. To give an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's lambda functions. Now this is a concept that gets overlooked quite often, but lambda functions are very powerful. So lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But if since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36. Now, another thing that Lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example by them, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. All right. So if I were to call this function download file, and let's say that the URL is ftp colon // www.abc.org. Now if I were to run this, let me just run this here. It's going to perform these tasks. But the major advantage of using a function is now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL df ijk, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines. So this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see. And it's downloaded it, but as you can see that this step is now added to all 3 of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in 2 data and I perform some task. Now I want to return x multiplied by y. Let me call it, again, this is a very trivial example, multiply, right? And if I want to multiply two numbers, multiply, you multiply x and y. Now x and y are going to be numbers, so let's say 15 and be 10 comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it. So multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again, and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to, oh yeah, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now, as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute. Takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and sorry, multiply and we want to execute. If I run this, again it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. So there are multiple things that you can do, and lambdas are actually very powerful, but this is how you get started with it. Hopefully this was informative, and let's move on to the next. Now let's take a look at arrays in Python. So in Python, arrays are basically lists. Arrays are used to store multiple values in a single variable. As we've already taken a look at tuples and lists and dictionaries and sets, we'll be taking a look at a lot more in a future video, but arrays are basic programming constructs. In Python, you have arrays in the form of lists. So you don't call them arrays, you call them lists, which sounds more readable and more intuitive. So Python does not have a built-in support for arrays, but Python lists can be used instead. So you can, instead of creating three variables to store all the three strings as we have done in the code listed below, like this, we can do it in an array and we can just use them ourselves. So there are many operations that you can perform in an array, and we'll take a look at all of them one by one. First is we can access an element in an array. So accessing an element basically means we'll be accessing it using its position in the array. So if it's at the first position, we use the 0th index. 0 is the index is the number inside the parentheses after the array name. Similarly, if it's the second, then we use 1 because it's indexed from 0. And if we use an index that's not present, then we get an error. Index range error, I think it's called. Then there's modifying the element. Now, if you're using a tuple, that's not possible, but in lists, it's completely possible. So instead of doing something else, you could just modify the element using the same thing that we did previously. You can take a look at the length of the array. Length basically means how many elements are there in the array. We can loop over an array and perform tasks the way we want to. We can add an element to an array using the append method. That would add an element at the end of the array. We can remove an element from a given position. So we could go cars, which is the name of the array, dot pop 1. This will remove the second element in the array. If I were to not give an argument, then it will remove the last element automatically. Instead of passing in 1, if I had passed nothing, then it would just remove BMW from the cars array. Then we have removing specific elements. So if I have a specific element that I want to remove, I can use the remove method on the array. And we'll take a look at all of them. Then there's Python classes and objects. So classes and objects are quite interesting. They're very easy to understand. They're quite interesting to use, interesting to see, interesting to build applications out of. They are the fundamental building blocks of object-oriented programming, and we'll take a look at that in a later module. But here you need to understand what classes and objects are. So a class is basically a container or a blueprint that defines what an object should look like. And the object is basically the in-memory representation of a class. So since Python is an object-oriented programming language, almost everything in Python is an object. And it has properties and it has methods. So class is like a blueprint for creating an object. So in the example, as we see, we have given a class, created a class. And we said whenever you create an object of a class, this should have a property named X, and the value of that property should be 5. Now this is a very, very high level overview of classes and objects. We'll go into much more detail in a later video. But here you need to understand that the classes and objects are how they are related. Classes are the definition. Objects are the concrete implementations. Objects are what you use in the real world. Classes are what define what your object's structure should be. And then we come to file handling. So what is file handling? Let's take a look at that. So file handling is one of the most important aspects of any application that you use. It's used to permanently store data on a disk or on a network location or anywhere. We will need file handling if we have to read or write from the files. Python provides a really easy way for us to read and write to files. So there are many file operations that you can perform. Some of the most important ones are opening a file, reading a file, writing a file or creating a file, and deleting a file. So to open a file, the syntax is quite simple. You use the open method that takes in two parameters. First parameter is the path to a file, and the second parameter is the mode. So the mode basically is a single a string that is either R, A, W, X or something like this. If you pass in R as the mode, the file is opened in the read mode. That basically means that all I want to do in this file is I want to read from the file. I don't want to make any changes. I just want to read the data. The A mode makes it append. This means that anything that's existing in the file, don't overwrite it. Just add data at the end of it. Then there's W, which stands for write. This opens the file and creates it if it doesn't exist, and it overwrites any data that's already existing. So that's the difference between writing and appending. Appending adds data to the end of the already existing content in the file. Writing will overwrite everything. Then there's X, which basically just creates the specified file, and it will return an error if the file already exists with the same name. We can read the file using the read method. This will read the entire all the lines from the file into and show us that. We can also specify how many lines we want to read, and if you want to read it line by line, then we can basically just loop over it, and we'll take a look at all of that in the hands-on. Then to write an existing file, we must add a parameter to the open function. Now A would be, as I've already told you, to append a file, append items to a file, and W would be to write contents to the file, right? Then there is delete. Okay, so X is used to create a file if it doesn't already exist, and if it does already exist, then it will return an error. And finally, we come to delete. So deleting is basically allowing you to remove a file or delete a file that already exists. You can do it using the OS module. You can write os.remove, give it the path of the file. It'll check if the file exists, and if it does, it will be removed from the disk. So now finally, let's take a look at the hands-on of file handling. We'll take a look at what it means and how you can perform how you can perform file handling in Python. As of now, we only have a app.py file in our hands-on folder. So let's first try and creating a file. So I will create F as the file handler. Using the open function, I will write in the file name. Let's say it's sample.txt. And I want to create it, so I will use the X flag and I will close it. Closing a file is important because all the changes that have been made so far are made in an in-memory buffer. So when we use f.close, all those changes get written to the file. So make sure that you close the file so that the changes that you've made to the file gets persisted. Let me remove that. Run this, and now if I take a look at it, as you can see, sample.txt is already created. But if I run it again, I will run into an error that says file exists, which means that the file that I wanted to create is already there. So now that we have done that, let's try some other tricks. Now, the problem is whenever I use the open keyword, it's obvious that I want to close it as well. So instead of me having to write f equals to this and then write everything and then close it, I can wrap everything inside a with keyword. So with open file, and I want to write something to it as f. Now anything that I write within this block and it's indented, that would mean that I want to, after this block, I want to end or close the file. So instead of me having to manually write f.close, this will be done automatically for me. So let me just do this. Now let's just f.write, and what I want to write is sample line. Save it, run it. It's done. If I open, sorry, Control B, open it, and it's sample line written to it. But let me just add a backslash and then write sample line again. See what happens when I do this. I run this again and I open it. It enters sample line and then enters a new line. But if I were to then write something else, Or if I were to run the same code again, this would cause, I mean, it won't be the appropriate thing that I want to do. So if I do this again, it's got the same thing. Run it again, it's got the same thing. So instead of this being added to the end of the file, what's happening is the file is being opened, everything inside it is being removed, and then this is being added to it. But what I can do is, if I remove this, it put it \n, and I type a. Now if I run this once, and if I open sample.txt, it's there. As you can see, I've added a new line and here, and then remove a new line. Let me just remove it completely. Run it again, open sample.txt, there's a new line. Run it again, another line. And if I keep running this multiple times, as you can see, multiple times the line has been added at the end of the file. So that's what the append method does. Now if I were to just read from it, so for L in f dot read lines, and all I want to do is print L. As you can see, it's printing the thing that I want to print. If I were to just remove the \n from my side, this will print each line with a \n. So this is what it looks like. So we are able to read from the file, we are able to write to the file, and we are able to do a lot of things. So with that in mind, our file handling is done. Obviously, there's a lot more that you can do with the file handling things, but this should get you help you get started. It's very easy in Python, as I've already told you. Use the with keyword to avoid having to write f.close on every file handle that you've opened. If you don't use the with statement, then make sure that you're closing the file before ending the script, or your changes will not get written to the file that you're trying to write it to. So let's see what else we have to do. And with that, we have come to the end of on Python basics. Hopefully this was informative